Hello everyone, welcome back. In today's session, we will talk about the Heroes Collection libraries and the virtual articulator. Once again, we start with our project already created in the Zirkonzahn archive. All that is missing is for us to import the intraoral scans. For that, we can simply use the drag and drop function. Here we have a zipped folder sent to us by our dentist, and we can just drag it into the project. The software will automatically unpack the files and open the import mode, where we get a visualization of the scans. We can individually choose whichever scan we do not want to import by simply moving it over to the left. In this case, all we care about are the upper and lower jaw, so we leave them on the right. We also get the chance to rename the scans before importing. For example, if you want one scan to be a scan marker or use it as your wax up. Now we click on Import on the bottom right. Our scans are now imported and we continue creating the CAD project. As antagonist, we can simply choose any tooth in the lower jaw and then proceed with the anatomic crown selection for the upper jaw. With Control and left mouse button, we can copy the selection over to tooth 1.5 and 1.4. We will also add the anatomic pontic where the patient is missing a tooth. Now let's accept our selection and open the modifier software. Next, we continue with the login procedure. We choose our user and then select the license package we want to use. Since these scans are not articulated, we click on No and proceed with the model alignment. Once again, we can display the articulator for the side view window to verify our position. Following that, we use the automatic alignment function so that our scans jump into our predefined articulator position. If you want to switch to another articulator, we have the articulator list on the left where you can choose. If we do just that, the position of the planes will shift. We can now reuse the automatic function to reposition the scans accordingly. The same applies to all the other articulators in the selection. However, for this patient, we will focus on the Zirkonzahn PS1 articulator. Now that our scans are in position, we can activate our ghost models to make further changes to the model positioning. By right-clicking on the ghost model, we switch from edentulous to crown and bridge. I will switch to the other side and make some minor adjustments. Once this is done, all that is left for this step is to activate the plaster plane. We select the small-sized plane since we have chosen the small ghost models for our tooth scaling. Following that, we click on Save and Proceed. We find ourselves now in the tooth placement mode. Let's go over to the group window and display the lower jaw and articulator to better understand how this patient is positioned and to get a sense of where the difficulties of the case lie. Some quick additional functions about the group window. While working with intraoral scans, we always have the option to toggle the textures on and off. And by right-clicking on any scan, we can immediately delete it from the scene or save it in the project folder. Okay, so the next step for us is to open the tooth library on the button here. As we can see, our 4 posterior teeth have already been selected and positioned. However, they are currently scaled to the medium-sized plane. But we will fix that later. Now I will show you what the Heroes Collection libraries have in store for you. To demonstrate this, I will add some additional teeth. By holding the left mouse button, I can easily add whichever tooth I want. I can even load lower teeth. We start with the Crown and Bridge library. Here we have 11 different tooth shapes, each with a different anterior and posterior morphology. Each shape exists with an original incisal edge and occlusal third and an abraded version. If we activate the analysis mode, we can see how the occlusal contacts are shaped. Our Crown and Bridge libraries are set up in a canine-guided occlusion and are loaded in as such. Next, we have the Pontic libraries, which contain predefined ovate Pontic shapes. These also exist in original and abraded versions. Then we have the gingiva libraries, where we can activate the pre-designed soft tissue. These exist as FP1 with a small connecting tissue, or FP3 with small, medium, or large gingiva lengths. Finally, we have the denture teeth, which are all set up in group function. These exist, in addition to the original and abraded versions, also with single posterior teeth and already pre-made posterior elements, which are very handy while designing dentures, but I will show you these once we touch on the denture module. For now, we return to the Crown and Bridge libraries. I deactivate the teeth I don't need in the FDI scheme and choose my 4 posterior teeth. As you can see, the modifier is very flexible. I can always add or remove teeth as needed. Now that we have selected our teeth, all that is left is to activate the plaster plane for proper scaling. Once everything is set up, we click on OK in the bottom left. Now let's have a look at the different movement options. The chain mode is already pre-selected if we have multiple teeth in our scene. In the previous video, we touched on the single mode, where each tooth can be moved individually. The chain mode will move all our teeth simultaneously, as if there were a magnetic force between them. Additionally, we also have built-in collision options. The interdental collision prevents the teeth from overlapping. As you can see, they push each other away. If we activate interdental distance, we can set our preferred value and modify, so to say, the magnetic force between them. As you can see, the teeth will now always maintain that distance from each other. In this case, it's 0 millimeters. We can combine the interdental distance with the auto resize in the chain mode. When auto resize is active, the teeth automatically scale depending on your movement. If we grab one tooth and move it into the others, they become smaller, and if we move it away, they become bigger. With this feature, we can position and scale the teeth simultaneously. We also have the occlusion collision, which functions the same as the interdental collision. If the collision is active, the teeth will not intrude into the antagonist. No matter where we move them, they will stay on the surface. Next, we have the all movement, which allows us to freely move all teeth at once. Additionally, we can also activate the precise movement, which repositions or rotates all teeth simultaneously depending where you grab it. And we can adjust the individual tooth axis by grabbing the yellow ball while the axis function is active. If a plaster plane has been selected, we can activate the plate movement. This allows us to move the setup via the plate, or to incline the occlusion plane by pressing Ctrl and scrolling. Now let's go back to chain mode. We start by copying this premolar shape to the molar. Right-click on tooth 1-5 and select Copy to. Choose tooth 1-6. Now we have a third premolar. Next, we start positioning the teeth a little bit better. By holding Ctrl, we can still rotate the teeth individually even though the chain mode is active. The same applies to scaling. If I press Ctrl and right-click on a tooth, that tooth becomes locked. It is visualized by these small red dots on the surface. This means that when I move or scale other teeth, this one will not be affected. Once the teeth are roughly positioned, we can fine-tune their palato-buccal dimension to better match the die. Now that our first premolar is in a good position, we will lock it. Next, we position the other premolars and then focus on the molar. We make sure we have proper contact points and briefly check the lower jaw. Once the basic setup is finished, we move to modeling and start freeforming. Using the Teeth Parts tool, we shape the tooth to match the die while pressing Ctrl or Shift. With that, we can work very precisely. If something unexpected happens, we can always undo any modification. In this situation, the interdental collision is still active, so it repositions my teeth. Since I don't want that, I deactivate it, and we continue refining the shapes. For the pontic, we will narrow it basally slightly. Always try to grab a large portion of the tooth while shaping to maintain the tooth harmony as much as possible. Once the general shape is done, we focus on the contact points. Now, once we are happy with our teeth, we can activate the virtual articulator. If we click on Articulator in the taskbar, a drop-down menu opens up where we have 3 options, but in this case, we only focus on movement. The articulator immediately detects intersections between the upper and lower intraoral scans. We need to remove these. For that, we have 4 options. We can move the lower jaw down in the Z-axis. We can cut the scan intersections. We can disable the collision of the antagonist, or we can open the articulator pin. In this case, we choose Cut Scans. Now we can cut the intersections only in the upper jaw, only in the lower jaw, or both jaws 50-50. If you are not planning to design a mock-up or bite splint, I would usually always go with Cut Both. As seen here on the texture, these are the areas he modified. Now we can display the lower jaw and the articulator. On the top right, we now have a 2D interactive view of the articulator. The gray sphere in the middle controls the protrusion movement, while the 2 white circles control the lateral movement. The parameters below in the center control the inclination of the articulator table. Let's enter some medium values. We also have options to adjust the Bennett angle and condylar angle. Double-clicking resets values to the standard parameter. We can also restrict protrusive movement by moving the turquoise sliders further back. However, since the movement is currently guided by the articulator table, we change those values to 0 so that the movement is guided by the models. So in this case, if the model slides over the canine, we want to avoid that. By limiting the movement range of the protrusion, we can control this behavior. After that, we simply mirror the value to the other side. If we want our movement to be guided by the articulator table instead, we can right-click on the lower jaw and deactivate collision. Now the movement will follow only the table. If we reactivate the collision, the movement will again be guided by the lower jaw. The first step is always to cut static intrusions by clicking on Cut Static. After that, we can also include our designed teeth in the movement. We cut the intrusions first since the software would otherwise open the articulator pin. If we click on the white little arrow, we can incorporate the teeth into the collision group for the antagonist as well. The teeth are now influencing the articulator movement. For example, if I elongate this cusp, the movement will now be affected in real time, opening or closing the bite. In this case, however, we will undo this step to preserve our shape. Since we want to use only the models, we leave the teeth deselected. Now we run the simulation. Let's hide the articulator for better visibility. We can also display the summary antagonist, which shows all movements of the lower jaw that have been generated. This can also be exported as STL and 3D printed. Finally, we click Cut Dynamic. If we now return to free modeling, we can add material to the tooth surface and the dynamic movements are automatically removed, creating natural abrasion patterns. One last step. When we click on Next, our tooth setup is saved. If we go back, we can continue modifying our teeth further. Clicking on Next again allows us to save another setup version. Now that we have two setups, we can switch between the two and choose whichever we prefer for the following modules. If we return now to the Zirkonzahn archive, we can see that the two setups are also being saved in the folder. Thank you all for watching. Make sure to follow us so you don't miss the next video, where we will finish the bridge and dive deeper into the modifier software.